All right, so we start with what we know. This is what we know. So let's start with 13.5 moles of FeCl3. Do I need to put a 2 right here because there's a 2 right here? No, never. When do I use the coefficient 2? When I convert from moles of one substance to moles of another substance. And this is, yes, yes. So we start here, and we want to go to moles of chlorine gas. And so this is where we use the mole to mole ratio from our balanced equation. We want moles of FeCl3 on bottom. And we're looking for moles of Cl2, so that goes on top. Are you with me? Okay. And what is the mole to mole ratio? 3 chlorines to 2 FeCl3s. Good? That goes away, and we're left with moles, so that's it. You multiply 13.5 times 3, divide 2, and we should get 20.25 moles of chlorine gas. Good? Should we do one more? Okay, we're going to use the same equation. This time, let's say we start with 2.25 moles of, hold on a second. Well, let's just work one on the worksheet. So on the worksheet, on the back side, you guys all have this still? Anybody need one? Okay. So section 5, mole to mole relationships. How many moles of HCl can be produced by the reaction of 0.15 moles of PCl3? Now, if we read the top of this, it says, consider the following reactions when answering this whole page. Okay? So what equation are we going to use for this first one? First, second, or third equation?
First one.
First one, because we're dealing with HCl and PCl3. That's the only one with those in it. So we're going to write that one here, and you guys can just balance it right now. PCl3 plus H2O yields H3PO3 plus HCl. Okay? And it says we have 0.15 moles of PCl3, and we want to know how many moles of HCl we get. Good? You guys think you know enough to try it by yourself? Yes or no? The answer could be no. Okay, let's try it. What's our first step?
Balance it.
Balanced equation. Go ahead. Balance that equation, because you got to be good at that by now. Because if you don't have it balanced correctly, you're going to get it wrong every time. We good with balancing this equation? Where's a good place to start? We can either start here or here. Do you understand why? Biggest numbers, 3, right? So, yeah, where do you want to start? H3PO3, okay. Should we start with hydrogen, phosphorus, or oxygen? Hydrogen. Now, in general, I would leave this one for last. Why? Because it's everywhere. Multiple side. Appears multiple times on one side. But let's try it, see what happens. Yeah? Because why not? We can. So we have 3 plus 1 on the left side, or on the right side, and we have 2 on the left side. If we try putting a 2 right there, now it's balanced, right? Are we good? But look what it does for oxygen. We have 2 on the left and 3 on the right. That's why I saved that one for last, because we're going to have to start over anyway. Good? So if we start with oxygen, there's 3 on the right, so we put a 3 right there. You follow? And that gives us 6 hydrogens on the left. We have 3 here and only 1 here, so we have to put a 3 right there to make sure that we have 6 on the right. You following? And by putting a 3 right there, that gives us 3 chlorines on the right. We already have 3 on the left, so we're good there. And we have 1 phosphorus on the right and on the left. So that's it. Good? I could have started with chlorine just as easy. Still got the same thing. But that's why I save hydrogen for last, because it appears multiple times. Sometimes that you don't have any option, but that's what you got to do, okay? But when you have an option, let's do it. Okay, now what do? Start with what we know. 0.15 moles of, and include everything, ladies and gentlemen. Don't try to, oh my, I don't have to write all this crap down. Yes, please do. If you're organized, you'll get it right every time. If you're not, you'll mess up. Not every time, but you will mess up. Okay? So we got to convert moles of PCl3 to what? Did I give you guys the mole roadmap? Yeah, let's use the mole roadmap. Moles of PCl3, what can we convert to? Can we convert directly to moles of HCl, what we're looking for? Is there a path from moles of one substance to a moles of a different substance on that map? Yes? No?
Coefficients of balance equation?
Yeah. Right smack in the middle, moles of A to moles of B, or moles of B to moles of A. Doesn't matter which way you go, right? Because A and B is just arbitrary letters. Okay, we can say this is A and we're going to B, or this is B and we're going to A. Doesn't matter. So we put moles of what on bottom? PCl3, so it cancels, and we're looking for moles of HCl. Let's put that on top. And what's the mole-to-mole ratio? What goes on top? 3, because that coefficient in front of HCl and the coefficient in front of PCl3 is a 1. Good? So moles of PCl3 go away, so we just multiply this by 3 and get 0.45 moles of HCl. Are we good with this? Pretty straightforward? If it's not, then don't say yes. Anybody have any questions? Doesn't have to be straightforward. I just need to know so I can know if I need to go deeper. Yeah, Bree.
I don't think I was here when you
Bryn.
went through the roadmap thing.
Okay. So,
Just here's a quick rundown.
yeah. Definitely. So you get it on your periodic table that I give you for the exam. So let's see. Here it is. So we got moles, and the one on here starts with a B. It doesn't matter if you start with a B or an A. You get that? So we could just do B because that's what it is. Oh, sorry, it's not moles. It's grams. Sorry. Grams of B. We can convert grams of B. The only thing we can convert to is to moles. And then from moles of B, we can go to particles of B. And how do we do that? From grams to moles or moles to grams, we use the molar mass. Do we all understand the molar mass? Yes? No? Okay. And then what do we use to go from moles to particles, particles to moles? Avogadro's number, 6.022 times 10 to the 23. Because 1 mole of anything is that many particles. And particles could be atoms, could be ions, could be molecules, right? Are we good with all of that stuff? Okay. And then we go from moles of substance B to moles of substance A. And notice these arrows are double. We can go from either side. And then we could just grab all of this stuff and flip it upside down and call it A, right? Same thing. So moles of A to grams of A, moles of A to particles of A. And we do it the same way. Moles to grams is the molar mass. And moles to particle is Avogadro's number. And how do we go from moles to moles? Moles of one substance to moles of another substance? We use the mole to mole ratio found on the balanced equation. Good? Just the coefficients.
So if you know, like, it's basically telling you if you know particle B, just telling you where to convert
Yep.
from there.
It's a roadmap. Tells you, because a lot of times you think, oh, I don't even know where to go from here, right? Best place to go is the thing is working. Okay. And so this tells us where to go. So in this case, we're starting at moles of PCl3, and we can either start here or here, doesn't matter. One of them. If we want to start at A because A comes before B, great. And we want to go to moles of a different substance, so that's moles of B. How do we do that? We use the mole to mole ratio from our balanced equation, which is 3:1. Everybody follow? Thanks for asking.
That helps a lot. Now I understand what that's.
Good. Any other questions? Yeah, if you're not understanding this, you're not helping anybody not saying anything. Okay, so yeah, please talk to me. Okay, so let's see. Do you want to try another one together, or do you want to do another one on your own? How you feeling? You got two more on this worksheet from section 5. That's just like this. Use just the mole-to-mole ratio. Another one on together? Yeah, which one? Second or third one?
Let's do
The third one? Okay. Okay, it says how many moles of O2, how many moles of O2 would be consumed by the reaction of 1.25 moles of C2H5OH? So first of all, what's our first step? We have to have a balanced equation. If we don't have one, can't do anything. So what equation are we going to use? First, second, or third? On the top of this sheet? The third one down. So it says C2H5OH plus oxygen gas gives us carbon dioxide and water. So we have an equation. Now we must balance it before we can do anything. Let's start with this big old yucky one at the front, right? Has the biggest numbers. So we can start with hydrogen. It has 6 hydrogens on the left, right? So what number needs to go here? 3. So that we have a total of 6. We have 2 carbons on the left, so we better have a 2 right there. So that we have 2 carbons on the right. Are you following me, or should I break it down and show my work? What do you need? You want me to show my work? CHO and CHO. So we just counted the hydrogens here. There's 6 on this side. We put a 3 here, so there's 6 on this side. Good? Then we counted the carbons. There's 2 on the left. So we put a 2 right here so that we could have 2 on the right. Now the last thing are the oxygens. Let's start on the right side because it's already balanced. 2 multiply 2, that's 4 here. 3 multiply 1, that's 3 there. That's a total of 7. Now we got to have 7 on the left. Don't forget we have 1 right there, and we have the O2. So this is always going to be an even number. We should make it what number? Yeah, put a 3 there to make us to have 6, plus the 1, that's a 7. Good? Do we feel pretty confident balanced equations yet? If we're not, we need to practice some more. Okay? All right, so this problem says how many moles of O2, thank you. How many moles of O2 would be consumed by the reaction of 1.25 moles of ethanol? Okay. Let's start with what we know. What do we know? 1.25 moles of ethanol. And we look at the mole roadmap. We start at either moles A or moles B. And we want to go to moles of a different substance, so we're just doing the mole-to-mole ratio. That's it. Moles of C2H5OH. Are you following me, or am I just talking and doing it myself? How you feeling? Okay. Seeing some nods. I'm not seeing any head shakes, so we're good. Moles of O2 on top, because that's what we're looking for. And somebody tell me the mole-to-mole ratio here. What goes on top? How many moles of oxygen go on top? 3, because of the coefficient on our balanced equation right in front of oxygen. What goes on bottom? Just 1, because there's not a number in front of C2H5OH, right? That means it's 1. So that goes away. And we just multiply 3 to both sides, or just to both sides, sorry. We just multiply 3 and then divide 1, and we get 3.75 moles of O2. Are we good? Yeah, Sandy.
How did you figure out there was 3 mole of O2?
Good question. Thanks for asking. Right here. The coefficient of our balance equation. And it was to 1 here because there's not a number there, and that means 1, right? You with me? Okay. So that's why you have to have a balanced equation before you do any of this stuff. Okay? Any other questions? Do you want to try the last one on your own, or are you ready to move on? You move on? Okay. All right, so the next thing we got to do is go from moles to mass. So if we have another balanced equation, Al2Al2O3 to 4Al plus 3 O2s. So we have a balanced equation already. And let's say we want to know how many grams of aluminum will form in the reaction of 12.4 moles of aluminum oxide. Since our equation is balanced, we don't have to do that, or we should maybe check just to make sure. But we can see there's 4 aluminums, 6 oxygens, 6 oxygens. We're good. Okay? Well, doesn't hurt to check. So let's start with what we know. We know we have 12.4 moles of aluminum oxide. And I'm looking for grams of aluminum. So what if we look at our mole roadmap, what can I convert to? Moles of aluminum oxide to what? If I go to grams, I use molar mass. Is that right? But that's only if it's grams of the same substance. If you look at our mole roadmap, if we're starting, let's say, moles of A, if we use molar mass, we're going to get grams of A. Do we want grams of A? No, we don't. So we've got to go to moles of a different substance because we're looking for a different substance. Does that make sense? So we put moles of aluminum oxide down at the bottom, and we want aluminum in our answer, so we got to go to moles of aluminum. Are we good? Okay, somebody tell me the mole-to-mole ratio. 4 to 2. Any questions on that? Okay. So moles of aluminum oxide go away. We have moles of aluminum, but we're looking for grams. Now we can go from grams, or moles to grams, right? Moles of aluminum go on bottom, so they cancel. And we want grams of aluminum using our mole roadmap. And what's the molar mass?
26.98.
So close to, can we just say 27? That's really close to 27, we can. If you're not sure if it's close enough, then don't round, okay? Moles of aluminum go away, and we're left with grams of aluminum. 12.4 multiply 4, divide 2, multiply 27, and we get 669 grams of aluminum. How you feeling? Yeah, Sandy.
Could you go over how you solve for the equations, so like times and divide?
Uh-huh, yep. So we got 12.4. We're going to start there because that's our first number, right? Then this little dot here means multiply, right? So I can multiply. I'm going to multiply by the top number. So I multiply by 4. And then this line means divide. So then I push divide 2. And then I have another multiply, and I'm going to multiply what's on top. Multiply 27. And do I have to worry about dividing 1? But can I? Yeah, either way. Yeah.
Can you explain how you got to 27 one more time?
Yes. Because this is moles to grams. So if we look at our mole roadmap, when we're going from moles to grams, we use the molar mass. And the molar mass of aluminum is just the atomic mass of aluminum. But if it's a compound, we have to add the atomic masses, right? Remember? Okay, good.
Okay.
Any other questions? Thanks for asking, guys. Keep asking.
Question.
Yeah.
So if it was going from moles to moles, it would just be the coefficient, but since it's from moles to grams, you'd add the
Well, we have,
whatever.
yes,
Yeah.
we have to know grams of what. So in this case, it's grams of aluminum. So that's why we know we have to go moles of aluminum oxide to moles of aluminum first, so then we can go to grams of aluminum. Does that make sense? Anybody else have a question that you're just not understanding? How we know what to do? Because that seems like the biggest question, right? How do you even know what to do? Because it looks a little bit scary at first, yeah? Are we good? Okay. Okay, let's let's do one more together, and then I'll have you do some on your own. All right, so let's use this same equation. And this time, let's say we obtain 38.4 grams of oxygen. We want to know how many moles of aluminum we should get as well. So I want you to recognize something here. Last time we started with our reactant and we converted to one of our products, right? This time we're starting with our product. Can we convert to our reactants? Yeah, we can. But in this problem, we're converting to another one of our products. We could do any one that we need in our same balanced equation, okay? So in this case, we're going from grams of oxygen to moles of aluminum. So if you want to plan it out on your mole roadmap before you get started, yeah, let's do it. Where are we starting? Grams of A. That A will be our oxygen, right? And the only thing that we can do is go to moles of oxygen. You following? Once we have moles of oxygen, we want to go to moles of a different substance, so then we go to here. That's our path. You follow? So we're going to use the molar mass to convert to moles of oxygen, And then the mole-to-mole ratio to convert to moles of, what are we looking for? Aluminum. So we're going to start with what we know. Always start with what we know. 38.4 grams of O2. And what's the molar mass of O2?
32.
Good. I get a lot of people will say 16. There's 16 for one oxygen, but there's O2, so we have to multiply that by 2. So we got 32 grams of oxygen for every 1 mole of oxygen. Grams of oxygen go away. We don't want moles of oxygen in our answer. We want moles of aluminum. So moles of oxygen to moles of aluminum using the mole-to-mole ratio, which is what? 4 to 3. 4 on top to 3 on bottom. Any questions how we do that? Yeah, Britt.
I feel like this is where I usually make the mistake is when it has a O2.
Uh-huh.
I usually will do like, I'll get that you have to multiply the number by 2, but then I feel like I always put the 2 moles of O2. So it's just a singular mole of O2 even though there's 2.
When we're converting, so you got to understand what the units of atomic mass are. So for oxygen, the atomic mass is 16 grams per mole. And what does it mean per mole? Per 1 mole, right? So if we have O2, then we have to multiply this whole thing by 2, and that's 32 grams per, again, 1 mole. It's always per 1 mole. It's just like when you drive down the highway at 75 miles an hour. It's 75 miles for 1 hour every time. Follow? Did I answer your question?
Yeah, it's just my
Mind game?
fault in there. Yeah, but it makes sense. I just need to catch myself and not put the 2 on.
Yeah.
Just keep it.
And here's something else that might help. When do we use these coefficients, guys? There's only one place we use them. When we're going from moles of one substance to moles of another substance. That's the only time we use them. Good? You still have to practice this to get it down. I get that. And so now we do 38.4 divide 32, multiply 4, divide 3. Are we good? And we should get 1.6 moles of aluminum. Any questions on that?
I have a question.
Yeah, Andrew.
So in our equation we started with, it was 2 aluminums for the ratio.
So
That doesn't matter.
this right here,
Yeah. That's just
that's aluminum oxide.
Oh,
Are we dealing with aluminum oxide in this problem? No, we're not, so we don't use that. Good. Make sense?
yeah.
So this is saying if we produce 38.4 grams of oxygen, we should also produce 1.6 moles of aluminum. If everything went perfect, that's what we would get. These are just predictions, guys. When I say just predictions, they're great predictions. But if we mess up on our measuring in the lab, yeah, we're not going to get this, right? Any other questions? Yeah, Sandy.
Sorry.
No, you're good.
I think you answered this in the beginning. So how do you figure out where you're starting from the, like the path, either mole B
It
or
has the same thing.
mole A sign?
Yeah, it doesn't matter if you want to start at A or B. Now, we created this map so that it's easy to follow, and A comes before B. So if you want to keep it straightforward, you start with A and you end with B. Good enough? Yeah,
And then to know if you're starting with either moles or grams, is it based on what the problem is telling you?
that's right. You'll list. So remember when we did dimensional analysis the first of the semester? First step is, what are we looking for? We have to know that, otherwise we can't do anything, right? And our next step is, what do we already know? So yeah, we start with what we know and then convert to what we're looking for. Good? So what we know is our A, what we're looking for is our B, for example. Good? Any other questions? Great questions, thank you. All right. Do you want to try some of these on the worksheet? Section 6. We did 2 together. Do you want to do it on your own? Yeah, let's do. Either the first or second or third. I would start with the first. Did you ever try that again? Did it work out? It didn't? Oh. Did anybody else try the stoichiometry homework in mastering chemistry?
I started it.
Okay. If anybody else has problems with it, just email me. And I know it doesn't help you get practice, but we'll make it right, okay? But I haven't figured out why it's doing that. Yeah, we're doing that one right there. Mhm. starting here, and we're going to here. We're starting here, and we're going to here. Does that make sense?
Yeah.
Do you have the balanced equation? Are these all balanced?
Mm-hmm.
Go ahead and take a minute and balance these. Just right here. And then it's done for the rest of the page. And if you have a question on it, let me know. Anybody feeling like it's just way over your head? What part?
Beginning.
Balancing? Oh, so, did I give you some practice worksheets? Did you do 'em? Okay, so, we gotta get this down, because this is for the rest of the semester, right? Okay, so. Let's just, you doing this one first? Yeah, so you, did you write it correctly? So double check, make sure you wrote it correctly. Okay. So where do you want to start? Well, let me tell you something. You can start wherever you want, wherever you want. Maybe just start right here, because that's the beginning. And, because I gave you those tips and tricks, are you worried about what tips and tricks to use? Forget about it. Forget about that. Let's just start here. Okay. So, what do you want to start with? P or CL? Make sure when you do this though, this is capitalized. Just so you know that it's chlorine, right? Alright, so start P. How many P's? So do you want to write it out? So we got P, we got Cl, and we got hydrogen, and we got oxygen. Alright, so how many P's do we have on this? One. So I'd say equals one, so we just don't make it. And how many do we have on this side? Okay, equals one. Okay, now let's do Cl. How many do we have? Three. How many do we have over there? So, oh, don't put one. Let's make it B3. Now it has three, right? Because if you just put one, you're gonna have to erase it.
Okay.
Does that make sense?
Yeah.
You can if you want, it's just gonna have to erase it. And now we just changed something, didn't we?
Yeah.
So let's do hydrogens next. We have three here and three here. That's a total of 6. How many do we have right here?
2.
So then put 6 there. We have 2 here, so what number needs to go there?
3.
And now we have 6. Does that make sense? And then, now the last one is oxygen. We have, how many here? 3. And how many here?
2. Oh, wait, 6.
What does that 2 go to? That 2 only goes to this. H2O. The number comes after the letter. Let me get that down. Okay? So there's, but this 3 goes to everything.
So
How are we feeling? Did anybody get different answers? You want to go through one?
What are we doing?
What's that?
Well, I thought we were doing the first one on section six.
Section 6.
Section. Did I do the wrong one?
Yeah, you did 5.
Uh.
You did about 5.
Maybe I'm not.
Well, did I give you these right answers? Yeah. I took the wrong picture. Oh, I'm sorry. Gosh. Let's try that again. I gave you the right answers, but gosh. Those are the right ones, right? Okay, so we got 1.28 moles of H2O, 40 grams of O2, and 0.093 moles of CO2. Okay, now do we have any questions? Sorry. Did I make you do the other ones?
No.
Okay, good. Yeah, Sandy.
Oh, wait, never mind, I did do the other ones, never mind.
So, we're ready to move on, or do you want to do one?
We do one?
Yeah, which one?
The first one.
Okay, yeah, let's do it. So what equation are we going to use? This top one, right? PCl3 plus H2O forms H3PO3 plus HCl. Now we got to balance. Did we already balance this equation? Yeah, so this is going to be a 3 here and a 3 here, and we got it, right? All right, so let's see. We have 35 grams of H3PO3, and we want to know how many moles of H2O we get, or that we react with, okay? So what are we going to start with? What we know. We have a balanced equation. That's what we should start with, and we did. And then we start with 35 grams of H3PO3. And what does our mole road map tell us we have to convert to? We have grams of substance A.
Molar mass.
The only thing we could do is go to moles, right? So the molar mass of H3PO3 is, did anybody calculate it?
82.
What is it?
I got 82.
82? Yeah, that's it. 82 grams of H3PO3, so that they cancel, right? How many moles on top? Just one. And it's the same substance because of our mole roadmap says grams of substance A to moles of that same substance, right? So that goes away. Grams of H3PO3 go away. And we are looking for moles of H2O. So we're not there yet. So how do we go from moles of one substance to moles of another substance? Mole to mole ratio. What is it? 3 moles of H2O on top, because that's what we're looking for. To how many moles? 1 mole of H3PO3. That goes away. We're left with moles of H2O. That's what we're looking for. That tells us we can stop converting. 35 divide 82, multiply 3, should give us 1.28 moles of H2O. Okay? Questions? Yeah, Connor.
Might have been because I was late, but where'd you get the PCl3?
This right here,
Like the balancing.
top here, these three balanced, so do you have this worksheet?
Yeah.
These three equations go to this whole page.
Gotcha.
Great question. Yeah, if you're not sure what's happening, please ask. Good? Okay, what do we need? Do we need another one of those, or are we ready to move on? One more? Practice on your own? Or together? What are you feeling? Together? Okay. Let's do the second one. I'll do one more. You want to do the second one or the third one? Second? Okay, let's do second. Okay, this time, let's pick so we want to know how many grams of O2 react with 2.5 moles of xenon difluoride. So let's use the equation. It's the middle equation. So I'll just write it here. We have XeF2 plus H2O yields Xe plus HF plus O2. What's our first step? Balance it. You want me to show my work here? Okay. Xe, F, H, and O.
It's not writing.
Uh-oh. There it is. Okay. Okay, where do we start? So we first have to balance this. Which one do we want to start with? No, you're good. Hydrogen, you say? Well, let's just start with whatever you want. Forget if balance equations is throwing you off because you have to remember all those little tips and tricks, then don't. You could still do it. Okay? Don't make that be the hard part. If it is, throw it out. So let's start with hydrogen. We have 2 here. We have 1 there, so we better put a 2. Hydrogen's balanced. Well, we just changed something, right? We changed this, so we better count fluorines next. We have 2 on the right. We have 2 on the left. Great. Let's just count xenon, because we just counted the fluorine. We got 1 on each side. Good. Oh, for crying out loud. Now we got to do oxygens. We have 1 on this side, 2 on this side. What do we got to do? Oh, we got to put a 2 right there. Now do you see why I have those tips and tricks? You could still do it though. All you have to do is just keep going until it's done. So now we have 4 hydrogens on this side. So we better put a 4 right here. And now we change now we're just starting over again, right? So we better put a 2 right there and a 2 right there to make sure that we have 4 fluorines on both sides, and then that'll make so that we have 2 xenons. And now oxygens, 2 apiece. So you can still do it. Not a problem. So if you want to get rid of those tips and tricks, then do. Okay? A little sloppier, but okay, we got it. And if you use a pencil, easy to erase. Just get a big eraser and you'll be good, right? Okay, so let's go ahead and do the problem now. We start with what we know, 2.5 moles of xenon difluoride. And we want to go to grams of O2. I'm going to write that right here so I can know. Okay, I'm at moles of substance A. Where do I go? I want to get to a different substance, so where do I go? Moles of substance B, right? Because in the end, I want to go to B anyway. So what's the mole-to-mole ratio of this to oxygen, right? We have 2 moles of XEF2 on the bottom, so they cancel, to 1 mole of O2 on top, because that's what we're looking for. You following? That goes away. Now we have moles of substance B. We want to go 2 grams of that substance B. So how do we get there? Molar mass. If we have 1 mole of oxygen, do you all understand why it's 1 mole? Molar mass is always for 1 mole. And what's the molar mass of oxygen? Almost. 32 grams of O2 because there's 2 of them, right? Ladies and gents, I even made that mistake while I was teaching. It's easy to. You just got to pay attention, okay? Slow down. And we have grams of O2. That's what we're looking for. So that tells us we can stop. And we should get 40 grams of O2. Good? How comfortable, confident do you feel on this? Ready to move on to the last one? Well, it's the last conversion factor, and then we got to do percentages. You guys understand percentages? No? Yes? Okay, here we go. We'll get there. One step at a time. All right, now, you guys are in lab class, yeah? No? Can you measure how many moles that you have? No, you can't. So why do we use it? Did we learn why we did it? Why we use moles? So that we can convert. So that we can predict how much product we get, how much reactants we need. That's the whole point of it. Okay? And if we use moles, we don't have to use 6.022 times 10 to the 23 ever again. Okay? But we use that to kind of show us why we can do moles. Yeah? All right, so what we really do is go from grams of one substance to grams of another substance. So far we went from moles to moles, grams to moles, or moles to grams. But in the end, we're going to go from grams of substance A to grams of substance B. It's just one extra conversion factor. So we added one, now we're going to add another. Make sense? All right, so let's use this equation. Potassium sulfate plus barium chloride gives us 2 potassium chlorides and barium sulfate. What kind of reaction is this, ladies and gents?
Double swap.
It's a double replacement reaction, so is it redox? That means it's not redox. If it's double replacement, it's not redox. It must be either acid, base, or precipitation. What is it? Precipitation. Which one is the precipitate? Which one forms a solid? KCl or BaSO4? Use your chart. Get that down. Either that or put your chart on your little reference card. BaSO4. Sulfates are soluble except when they're with barium, 2+, right? Okay, so you can have that on there, you just can't have everything else you had so far. You got to pick and choose. So decide what you're going to put on that card and memorize everything else. Good? All right, that's not this problem, but okay. It will be later. Okay, we have a balanced. Do we have a balanced equation? There's this 2 here. Does that mean it's balanced? Can you always check? Yeah, let's check to make sure. 2 potassiums, 2 potassiums, 2 chlorines, 2 chlorines, 1 barium, 1 barium, 1 sulfate, 1 sulfate. Yeah, we're good. Okay. So let's say we have, we want to know how many grams of potassium sulfate we need in order to completely react with 29.8 grams of barium chloride. That way we don't have any leftovers, right? We don't waste anything. Where do we start? Now that we have a balanced equation. With what we know, right? You get the pattern so far? You always start with what you know. 29.8 grams of barium chloride. And what is our mole? So that's like our grams of substance A, right? What does our mole roadmap tell us we got to convert to? Moles of that same substance, right? Using the molar mass. So the molar mass of barium chloride is something. Barium is 137.3 plus 2 chlorines at 35.5 apiece. 71 plus 130.
208.3.
Thank you. 208.3. And that's grams of barium chloride. What goes on top? How many? Remember, this is 208.3 grams per mole, right? How many moles? Just 1. So that grams of barium chloride go away. Now what does our mole roadmap tell us we can do? We want to go to something else eventually. So now we go to what? Moles of something else, right? The mole-to-mole ratio. Exactly. Moles of barium chloride, and we want to go to potassium sulfate, so we're going to convert it to moles of K2SO4. And what's the mole-to-mole ratio? 1 to 1. Do we even have to do this one? No, but please do. Right? Just do to keep everything organized so that you know you're doing this correctly. So moles of barium chloride go away. And cancel that out as you go, ladies and gents, because you could flip-flop them on accident, right? And if they're not the same, they will not cancel. So double check to make sure they're the same top to bottom so they cancel. Good? And now that we're at moles of our substance that we're looking for, now we can convert it to grams, the last thing, right? So if we have 1 mole of potassium sulfate, we figure out the molar mass of potassium sulfate, which is something. Potassium is 39, what is it?
39.10.
39.1, we'll multiply that by 2, plus sulfur is 32, plus oxygen, multiply by 4 is 16, multiply 4. 174.27 grams of K2SO4. Everything cancels except for what we're looking for. That's not what we're looking for. We'll look for this right here. And that tells us we're done. And if we do this, we'll get 24.9 grams of K2SO4. Does that make sense? Just one extra step. Yeah.
If you don't round the molar mass, is it really gonna, like, if you were to just do 36 instead of 35 and a half, or round? down
I wouldn't
to-
round that much.
Okay. Would
So
you-
what it is on the periodic table is 35.45. I just did 35.5 because it's just to get it. And again, you don't have to round.
Okay.
If you want everything to be, but why is it okay to round? Because that's just the average, isn't it? So in every case, is it going to be exactly the average? No, it's not. And that's why it's okay to round, but I wouldn't round a ton. Okay?
Would you just say it's safer to just keep it the decimal
Yeah.
flat and straight across?
You could. Because you got to use your calculator anyway, right? So yeah, just keep it. And maybe I shouldn't round, but. You want to do one more of those, or how you feeling? Just trying to get off early tonight because we got a break to get onto, don't we? No, I'm just kidding. How we feeling?
Could we practice one more?
Yeah, we could practice 10 more if you want. Let's do. Let's do the second problem on section 7. Yeah? Because this will lead us into the last thing for tonight. Sound good? Okay, so it says how many grams of HCl could be produced by the reaction of 59.25 grams of PCl3. So let's go ahead and write. We already have a balanced equation because we did this a couple times already. So balanced is 3 here and 3 there, right? Okay, we know what we have and we know where we're going. So this is a 3-step process. Do you want to look at the mole roadmap and plan our trip? Yeah, okay, here we go. Oh, where is it? There it is. So we're going to start here at grams A. So then we got to use molar mass to convert to moles A. Then from there we go to moles B, and then to grams B. That's our path. We good? Where do we start? We have our balanced equations, so where do we start?
59.25.
Yeah, 59.25 grams of PCl3. And we're going to convert that to moles of PCl3. So 1 mole of PCl3 has a mass of, and we've probably done this a million times, 137.3 grams of PCl3. You following? Grams of PCl3 go away. Cancel as you go to make sure you're doing this correctly. And now we use the mole-to-mole ratio, going from moles of PCl3 to moles of what we're looking for, in this case HCl. And what's the ratio? 3 to 1. Good? Moles of PCl3 go away. Now we have moles of what we're looking for, but we want grams of that substance, so we use the molar mass. 1 mole of HCl, mass of 36.5 grams of HCl. You following me? Or are we just copying? Okay? So our last unit is grams of HCl. That's what we're looking for. That tells us we can stop. And we get 47.19 gram of HCl. What do we call this? Is this what?
Your yield percentage?
This is not a percent, but it is our yield, right? This is what we yield or what we produce. We have a special name for this one. This is our theoretical yield. Why do we call it that? Is this what we actually get in the lab? No. This is based off of theory. It's pretty close. If we do a perfect job in the lab, this is what we should get, right? So this is the maximum amount of product produced in the lab, or produced when we actually do, when we do this, right? Maximum amount we can get. What do we call what we get in the lab? When we do this in the lab, we actually get something else, right? We call this our actual yield. The amount we actually produced, or that is actually produced, when we carry out this experiment or this reaction. Good? Are we good with those two terms? Now, do you guys know how to calculate your percentage on a test? Your percent correct? Can we do this in our without help? If we can't, then percentages are percentages. They're the same. No matter what it is, it's the same. So if we want let's say we get 35 out of 40 correct on a test. Even though our tests only have 20, right? Well, we'll just say 35 out of 40, for example. How do we calculate our percentage? What we get divided by what we're trying to get, yeah? Or the total. That's percentages. Well, so far that's not a percentage, that's just a fraction, and we calculated that gives us a decimal, right? How do you convert a decimal into a percentage? Multiply 100%, or move it over 2 places, right? This is percentages, and this is all we do here. So if we want to find percent yield, which we will have to know how to do this, how do we do it using these? Which one goes on top? Yeah, what we actually get, our actual yield, divided by what we're trying to get is our theoretical yield, the maximum we can get, the total, right? And then that gives us a fraction changed into a decimal. Then we multiply that by 100% to convert it to a percentage. We follow? Go ahead and calculate, do the last one on this worksheet. We already found the theoretical yield. Calculate your percent yield. you get?
78.31.
78.5-ish? So our actual yield is 37.52, and we got 47.19, right? For our theoretical yield. We all do this? So we get 79.5% yield. That means we need to make better measurements, right? Questions? Do we get percent yield? That's it. I mean, that's all for tonight. Unless you have any questions. If you want to do anything else, we can. Yeah.
Will you always give us the actual yield, or is that what
Yep.
okay.
We'll give that to you. The only other way you can do that is you actually do it in the lab, right? Yeah, we'll give that to you. So you'll have to calculate the theoretical yield and then find the percent yield. Yep. Anything else? Well, then have a great fall break. Don't forget about chemistry, but maybe study before you get on the break and then right after you get back.
So, no class Thursday or class?
No class Thursday, nope. So we're finished with chapter 5 and chapter 6, so we got chapter 7 next week, and then the test, the exam, the following week.
Did we cover stoichiometry yet?
This is stoichiometry.
Oh.
Yep. Thank you so much. Take care, drive safe.